So today I would like to explain about the activity 1. So my name is Benjamin Ho normal metric CE 210053. So for step 1 is using MATLAB, doing this block diagram and putting the value inside the block diagram. So set the input voltage to 240 and record the waveform. So the input voltage is 240 and the motor speed is 3700. So first we need to show the waveform of motor speed. It's going out through like this. And meter voltage $3,700. Motor Tokyo, something like that for the waveform. And last is the input voltage, like this. So for step 4, we're using MATLAB, doing this block diagram. And for step 5, we're changing the motor speed and get the input voltage and meter voltage. So we can change the value at here, change the RPM value. So we're doing is 400 and run it. We're getting the input voltage value is 26 and meter output is 26.02. So now we're going to 800. Also going here, change the final value to 800 and run it. So become the input voltage value is 52 and meter output is 52.04. So let's see the graph. So for 52 is 50 and above, so we get a 52. So at here it has displayed the 52 value, meter. So it's like 52.52, around about 52.04 for the graph. So next we're going to 1200. And run it. So the value exchange to 78 for input voltage and 78.06 meter output. 78 below 80. Also 78, about 78 for the graph. So now going to 1600. 1600. Run. So the voltage we get is 104 about, is correct. 100 meter is 104.1. 104. So next we're going to 2000. So next is 2000 and the input voltage is 130. Tachometer output is 130.1. So in the middle, 120 and 140. So it's 130, correct. Also same as the input out voltage. In the middle of them, 140 and 120. So it's 100. The value is 130. So now going to 2200. So the value is 143 and 143.1. Okay, this is the graph, and this is the graph for tachometer. So now we're going to 2400. 2400. Right? So the value we get is for input voltage 156. For the tachometer output is 156.1. So this is the graph for input voltage and graph for tachometer output. The last 2600, we get 169 for input voltage, and tachometer output is 169.1. So this is the graph, and this is the tachometer output graph. That's all for me. Thank you.
Very good day, Dr. Dirman. My name is Ishwarjit Singh, matrix card number CE200095, and today I'll be explaining about the activity 2 on the open loop and closed loop speed control system, which is this, right? So now I'm just going to show on how to do the simulation in Simulink MATLAB. So for the first one, what we need to do is we need to find out the input voltage for 2500 RPM speed. So we need to set the parameters as step time 0, initial value 0, which indicates there is 0 voltage since we want to find the voltage, and sample time would be 10 seconds because we want it the period to be 10 seconds. Alright, so after doing that, run the simulation, and over here we got the simulation result. Okay, so this break over here we can set it as 0, for instance. Here, run it, will be same, and this will be the RPM speed. Alright, so this is the graph that we get for the input voltage on 2500 RPM, indicating that it's actually 162.5. okay, and the next activity was to find the speed output by changing the brake. Right, so how to do it is, first of all, put the voltage value as 162.5, the one that we just found just now, and then we need to set the brake value. Alright, so for brake 0, we will be getting 2502 RPM speed. Then we change it to brake scale of 3 and run it again, and the simulation result that we get is 2271 RPM speed. Alright, and we can also see the simulation graph. Right, from here it goes up to 2271. Okay, this way is just the tachometer output. Okay, and then we change it to 6. Break scale of 6 and run it again. We get 2040. So if you want to see the graph, press the speed output and you can see that it reaches until 2000. Alright, 2000 and slightly above 2000, which is the 40, 2040. Alright, so now we change it to break scale of 9 and run it again. Here we get 1809. The graph would be going from 0 up to 1809. Alright, change it to 12 and run it again. Then we get 1578. Speed output goes up to 1500 and above, slightly above the 1005, which is 78. Alright, so 1578. Then we go for the break value of 15, break scale of 15. Run it again. We get 1347 for break scale of 15. And then what we will getting is 1347. Alright, then change it to 18 and we're getting at 1116 as indicated over here. Actually, this graph over here, we can actually zoom it and zoom out, right, to see the value. There you go. Alright, and now I'm just zooming it out. Okay, so, and the final one would be of break scale of 21. Run the simulink again, and we're getting at 884.6, which is up until here, right? So I'm zooming in to see whether it reaches. Yes, it reaches, and it does. It goes until 884, right, over here. Alright, so that's all for activity number 2.
Okay, hi, Assalamualaikum. My name is Farah Anis Nabila binti Shariful Bahri. My matrix number is CE180237. Okay, today I will present about activity 3, closed loop speed control system. Okay, this is the block diagram for closed loop speed control system. Okay, first of all, we set up the value for each components. For gains, set up for 200, and for saturations, okay, for upper limit is 240 volt and lower limit is 0. Okay, so now we can run. Okay, um we need to uh get the motor speed for brake scale. Okay, so we need to adjust the value for constant. Okay, first we put 0. Okay, so we can run. Okay, okay, so we get the value for rate scale 0, 3687. Okay, this is the graph. Okay, okay, next we change to 3. Okay, run. So we get the value 3456 RPM. Okay, next 6, run. Value is 3226 RPM for then brake scale 6 change to 9. So we get the value for 2000s 995. Okay, 12. We get 2765 for 15. Get 2534. So for 18, we get 2304. And the last one is for brake scale 21. We run. We get the last value is 2073 rpm. So okay, we show you the graph. This is the graph between the motor speed and brake scale. So that's all from me, and thank you.